Hey YouTube, today I wanted to show you something I've done with my Chicago Electric, i.e. Harbor Freight Tools welder. There are a lot of other videos on YouTube explaining what I've done, but basically I've converted this from AC output to DC electrode negative output. You can see in here the white wires, they're the thick wires coming in. Those are the AC leads off of the secondary on the transformer. That's going into a 150 amp bridge rectifying circuit. It is supposed to be a 3-phase bridge rectifier, but I did a little research and found out that if you just leave one leg alone, it'll be fine. So, and here you can see I have the output. I have one spliced up into the gun. That's the negative. That goes out to the welding gun. And then down here I have positive. You can see I have this lead here coming off. That's going to one of the legs on the capacitor. I also got this black wire coming off. This is actually the current carrying wire, and that's going up into this this homemade inductor. It's made of an old microwave oven transformer that I broke apart. You can see that's got 7 or 8 turns of number 6 gauge stranded copper wire. With these 3 modifications, really, the diode, the capacitor, and the inductor, the output from this welder is absolutely, it's superb. I'm amazed how well it holds an arc and how steady everything is. There's a few other things I've added as well. I've added this little 80mm 15,000 RPM fan. It is very loud. I had it left over from another project, but I'm using that to keep the diode bank cool here. As far as other modifications I did, any connection that was on the 120 side, the line voltage side, I soldered them if I could. I couldn't get all of them, but any of them I could get to, I soldered. I also added a different cooling fan, 120mm, like 80 CFM fan. That's a lot better than that piece of garbage that used to be in it. Also up here, this transformer is now what runs the drive motor here. What I did is I went in, and there used to be little taps, little wires that came off of these the secondary winding of the transformer, and that would go up and that would power this drive circuit up here. The problem is that when you start welding, when you strike an arc, your open circuit voltage goes from maybe like 24 volts on the low or 28 to 30 on high, down to like 16 on low and maybe 20 on high, so that you have a dramatic drop in your voltage going to the wire feed controller. So with this, you still get some drop, some variance in the voltage to this unit, because the actual line voltage on the 120 side will fluctuate slightly, but at least it's 1/10 as bad basically as it used to be. So that smooths out the the wire feed speed very well. I'm very impressed with that. Also back here you can see this little transformer hiding out. Oh, I can move the machine here quick. That little guy, that's the power supply for the fans. I got that going to a little homemade power supply, a little power regulator. It's got two 1 amp 12 volt voltage regulators, a little bridge rectifier there, and a capacitor. Anyway, those are those soldered connections I was talking about earlier. All of those I've soldered into the switches, so now they're a much better contact. So anyway, that about does it. The capacitor I use I got from eBay. It's I think it's a 50 volt 41,000 microfarad Mallory capacitor. I somehow doubt that it's actually going to test to its original specs. It seems like it's pretty old, but it definitely does hold a charge, and that's the important thing. So I guess all told, this is what I did here. It works very well. I'll put up some pictures of some beads I just ran with it. But if you have one of these laying around and you have about $50 to improve it, this is where I'd do it. Convert it to DC electrode negative. Thanks for watching. Bye.